Why do we have snowy winters and sunny summers? It's one of those questions, right? It seems simple, but the answer, well, it's one of the coolest things about our planet. So let's just dive right in. Why do we have seasons?
All right, so what do you think? What's the real reason for Earth's seasons? A lot of us have that go-to answer we learned in school, but what if I told you the most common explanation is actually totally wrong?
Let's start by tackling what I like to call the Great Seasons myth. We're going to go after that one big idea everyone has about our distance from the sun. Is that really what it's all about?
You know, the myth just feels so right, doesn't it? It just makes sense. We're warmer because we're closer to the giant space heater in the sky. But nope. The surprising truth is that the distance between Earth and the sun, it has almost nothing to do with why we have seasons.
And if you need proof, here's the absolute kicker. Get this. In the northern hemisphere, our hottest summer months happen when the Earth is actually at its farthest point from the sun. That's a position called aphelion. And our coldest winter, that's when we're at our closest point, which is called perihelion. I mean, that one fact just completely blows the distance myth right out of the water.
Okay, so if it's not the distance, then what in the world is it? Well, it all comes down to one absolutely crucial thing, the tilt. The tilt is everything. So let's meet the real MVP of the seasons.
And here it is, the magic number, 23.5 degrees. That's it. That's the angle of Earth's axial tilt. This little lean is what makes all the difference in the world. Seriously.
So it's not just one thing, it's actually a two-part combo. First, you've got the Earth's revolution. That's its year-long journey around the sun. And second, and this is the key, our planet's axis stays tilted at that magic 23.5-degree angle for the entire trip. It never straightens up, it's always leaning.
To really see how this works, let's take a quick trip around the sun with the Earth for one full year. We'll make 4 key stops along the way that define our seasons, the solstices and the equinoxes.
Think of these as the 4 official turning points in our planet's orbit. We've got the summer solstice up north around June 21st, then comes the autumnal equinox in September, followed by the winter solstice in December, and we wrap it up with the vernal, or spring equinox, in March. Each one kicks off a new chapter in the year.
So what's the big deal with a solstice? Well, think of them as days of extremes. On the June solstice, the northern hemisphere is leaning as far towards the sun as it can get. The sun's rays are hitting the Tropic of Cancer dead on, which gives us our longest day of the year. And then, you guessed it, the exact opposite happens in December for the winter solstice. This also changes where the sun appears to travel in our sky, as it seems to move northward or southward over the course of the year. Okay, now for the equinoxes. If solstices are about extremes, equinoxes are all about perfect balance. On these 2 days, the sun is shining directly on the equator. And what does that mean? It means that pretty much everywhere on the planet, day and night are equal, about 12 hours each. They're the perfect kickoff for spring and autumn.
All right, so this constant tilt has this really fascinating result. It creates what you could call a tale of 2 hemispheres, where the seasons are always opposites.
It's actually a beautifully simple system. When the northern hemisphere is tilted towards the sun, it gets hit with more direct, powerful sunlight. Boom, it's summer. But at that exact same moment, the southern hemisphere is tilted away from the sun, getting weaker, more spread out rays. So when it's summer up north, it's winter down south, and vice versa. They're always a perfect mirror image of each other.
So why should we care about all this? I mean, it's cool science, but what does it mean for us? Well, this simple little tilt has these huge, profound effects on absolutely everything. So let's take a look at how these seasons actually shape our entire world.
Oh, the impact is just massive. Seasons tell plants when to grow and tell animals when it's time to hibernate. They're the starting gun for these incredible migrations for birds and other animals. And if you go to the polar regions, the tilt creates some seriously extreme conditions, like months of total darkness, or the amazing midnight sun, where the sun literally just circles the sky and never sets for 24 hours straight during the summer. Can you imagine?
And just to give you a perfect example, check out the Arctic tern. These little birds are incredible. They fly thousands and thousands of miles, all the way from the Arctic to the Antarctic and back again, just so they can basically live in a never-ending summer. They're literally chasing the sun from one pole to the other.
So, if there's one thing you take away from all this, let it be this. The next time someone asks you why we have seasons, you'll know the real answer. It has nothing to do with how close we are to the sun. It is all about that simple, elegant, magnificent 23.5-degree tilt.
And that leaves us with one final thing to think about. Just imagine for a second. What if the Earth had no tilt at all?
What would life even be like? There'd be no seasons, no variety, just one constant climate, year-round, forever. It's that slight little lean that really gives our world its rhythm, its character, and all of its beautiful changes.